Hello everyone, welcome to video number 2. Today we're going to talk about absolute value inequalities. Basically it's the same thing as what we did in class today. The only thing that's different is there's an inequality sign. Your steps for solving them basically the same. We just have to do a couple of extra steps for this inequality sign. So all we're going to do is some examples, and then tomorrow when you come into class we'll see if you guys actually understand it. So basically you isolate your absolute value here. You're going to move the 4 over, and you probably know you add it. So it's the absolute value of x over 2 plus 6 is greater than or equal to 5. Once you get it to this step, that's when you would isolate, or it's already isolated, so you would actually split it into the 2 separate inequalities. When you do that, it's going to create a compound inequality. Basically what that means is you have 2 inequalities that is combined with an or an and statement. For example, you could have x is less than 2 or x is greater than 10. Or you could have a compound inequality where it's x is less than 6 and x is greater than 3. Okay? And we'll talk more about that in class tomorrow. So here, this will tell you if it's an and statement or an or statement, this inequality sign. This is a greater than. Okay? So the way that I remember it is greater. Greater than. Okay, so when I split it up, I'm going to have x over 2 plus 6 is greater than or equal to 5, or x over 2 plus 6 is less than or equal to negative 5. Okay, and hopefully you notice I switched the sign here. The reason why you have to switch the sign is because you made this into a negative. You always have to do that on the second one. Okay, then all you have to do is just solve each of these inequalities separately. I'm going to subtract the 6 over. So that gives you x over 2 is greater than or equal to negative 1. Then I'm going to multiply both sides by 2. So you get x over nothing because the 2 isn't there. So x is greater than or equal to negative 2. Okay. Here on this one you do the same steps. Subtract 6 over. Then you're going to multiply both sides by 2. So you get x is less than or equal to negative 22. Some of you might be wondering, why did I not switch the sign here? Because I was dealing with a negative. The only one we care about is this one over here. If you multiply or divide by a negative, then you switch the sign. This is positive, so it's going to stay the same. We don't really care about this one. Okay, so this says x is greater than or equal to negative 2, or x is less than or equal to negative 22. Okay, so that you would think you'd be finished. You have to actually do one extra step, and that's to graph it. And since this is about my 7th time making this video, I already have the graph made out for you. So it should look like this, basic number line. All we have to do is graph these 2 inequalities separately. So x is greater than or equal to negative 2. I'm going to put a circle at negative 2. I'm going to fill it in because it has the equal to under it. So filling it in lets everyone know that negative 2 is a solution. And then it's greater than. Greater than is going to go to the right. So it looks like that. X is less than or equal to negative 22. It's going to be a filled in circle again. This one is less than though. So that one is going to the left. So that would actually be your final answer. You have to have your inequalities, but you also have to graph it. Okay? For our next example, I have this one. Okay, so same thing, we're going to isolate the absolute value. So you need to add the 9 over. So that'll give you 4x plus 3 is less than 14. Then for your next step, you're going to break it up into your 2 inequalities. This one though is a less than sign, so it's not an or statement. Or only goes with greater than. This one is a less than, or the way that I remember it is less than. Okay, that's the way that I remember it. So it's going to be 4x plus 3 is less than 14, and 4x plus 3. Hopefully you know switch the sign, so greater than negative 14. Then you just solve both of those inequalities. So you're going to subtract 3 over. So you get 4x is less than 11. Then divide both sides by 4. So you get x is less than 11 fourths. But it's easier to put that down as a decimal, because when you graph it on your number line, the decimal is going to be easier to see. So x is less than 2.75, or 2 3/4. Here you're going to subtract the 3 over. You get 4x is greater than negative 17. Divide both sides by 4, and you get x is greater than, let's see, negative 4.25. Or negative 4 1/4. This is an and statement though. Okay, so I'm going to go ahead and graph it. Okay, let's see. I want to go from negative 4.25, so probably start at like negative 5, all the way up to 2.75. So 3 is bigger, so I'll make my number line like that. So I'm just going to go in between there. There's negative 4, negative 3, negative 2, negative 1, 0, 1, 2, and 3. And then I just have to graph them. X is less than 2.75. That'd be about right here. I'm not going to fill it in because it doesn't have an equal to sign. The less than is going this way. X is greater than negative 4.25. That would be about right here. Greater than goes this way. And statements should come towards each other, and it's where they overlap. Like this one really goes on forever this way, and this one really goes that way forever, but we want to know where they overlap because it's an and statement. That means it has to satisfy both of these inequalities, whereas an or statement only has to satisfy one. And statements usually come together, or statements usually go apart. Okay, that would be your final answer though. Okay. There's one more example I want to do, and then we'll talk about the special cases. So here's our next one. Just by looking at it right off the bat, you would think this is going to be an and statement because it's a less than. But look at what happens when I actually solve this. I have 1 minus 2, absolute value, negative 4x plus 6, close the absolute value. I can't combine these together, just like yesterday. So what I'm going to do is I'm going to move the 1 over by subtracting. That'll give me negative 8. Then I'm going to divide both sides by the negative 2. Since I'm dividing by a negative, this sign is going to switch. And it's going to be greater than or equal to positive 4. Okay? Now's the time that I'm actually going to break it apart because it's isolated. There's nothing on the outside. So I'm going to have negative 4x plus 6 is greater than or equal to 4, or, because this actually turned into a greater than, not less than. So when you actually determine if it's an or an and, it's when it's isolated. Students usually struggle with that. They want to always look at the beginning. It's when it becomes isolated. That's when you decide. So you have an or statement, and it's negative 4x plus 6 is less than or equal to negative 4. And then you solve each one of these. So I'm going to add or subtract 6 over. That'll give me negative 2. Then I'm going to divide both sides by negative 4. So I get x. I need to flip the sign because I'm dividing by a negative. So less than or equal to 1/2. Over here, I'm going to do the same thing. Subtract 6. So I get less than or equal to negative 10. Then I'm going to divide both sides by negative 4. Again, I have to flip the sign because I'm dividing by a negative. It's not because this is negative, it's because this one is. So that's going to give me 2.5. Or you could write it as 2.5. Okay? Then all you have to do is graph them. This is an or statement, so they should be going away from each other. Okay, I need everything from 1/2 to 2.5. So I might start at like 0, that should be enough. Okay, so I'm going to say x is less than or equal to 1/2. That's about right there. Notice I filled it in because it has the equal to sign, and less than goes this way. Okay, this one is 2.5, so right here says greater than, so I'm going that way. This one is an or statement, so x is less than 1/2 or it's greater than 2.5. Okay, that represents all of our solutions. So like 0 would be 1, -1, -1.5, or even these over here, 3.5, 4, 4.25. Those are all our solutions to this original inequality. Okay, now we're going to talk about the special cases. So just like yesterday, the special cases happens once you get it isolated and you have a negative on the right side. So here, this doesn't look like it's a special case yet, but when I move the 5 over, I get the absolute value of 2x plus 1 is greater than or equal to -3. Okay? When this is a negative over here, that should be a red flag to you that something weird is going to happen. So you really have to just think about it. When I have the absolute value of something, this left side, that's always going to be positive because the absolute value is going to make whatever number that is positive. A positive number is always going to be greater than or equal to, or not really equal to, but always greater than a negative number. This one's always negative. This one's always going to be positive. So what that means is this is always going to be true. So that means your answer would be all real numbers. That's a number sign, not a hashtag. So another way you could say that is with the all real numbers symbol, just like this. Okay, here's another example. The only thing that's different is here we have a less than or equal to. It's already isolated, so we don't have to move anything. This is still going to be a positive number, less than a negative number. Okay, that's never going to be true. You're never going to have a positive number be less than a negative number. So when it looks like that, you're going to say it's never true, so that means no solution. Or you can abbreviate that with this symbol. That means the empty set. That just means that you have a set of numbers with nothing inside. There is no solution to it. Okay? That's all that I have for you today. Tomorrow when you come in, I'll give you some problems to work on and we'll see if you guys actually understand this. See you tomorrow.